Hey guys, welcome to the stations 1, 2, 3, and 4 review video for the quiz. So let's get started with station 1. Here we go. So as you can see, we're going to do the top 2 problems, and then the rest of them are for you guys to do individual practice. So let's get started. So we have composite functions. Throw back to that. It's been a minute, but we're back. So we have f of x equals 2x minus 1, g of x equals 3x. Find f. Remember that this weird circly thing just tells us that it's a composite function. So we have f of g of negative 3. So a reminder that whatever is on this outside, or what comes first, is our outer function. This g is going to be our inner function. So what do we do first? We set up our outer function. So we have 2 times blank because we're substituting in g for negative 3. I'll rewrite it in case that's more helpful. So this also looks like f of g of negative 3. So we have 2 of blank minus 1. That's our f of x. Filling in g of x with our inner. So g of x equals 3x. So this is our setup here. So we have 2 times 3x minus 1. The next thing we're going to do, we can multiply these two together. So 2 times 3x is 6x. Bring down that minus 1. If this problem said f of g of x, we'd be done here. But we see, I'm going to go back to pink, this negative 3 right here. So I can plug negative 3 in for x. So I have 6 times negative 3 minus 1. That's negative 18 minus 1. That equals negative 19. If you have any questions at this point, you can call me or Miss Ava over. We'll be walking around. I forgot my answer key somewhere, so we're going to say that's right. Sounds good. So that was one composite function. Let's do another one. This one confused me, right, because it looks exactly the same, but it's telling us to find f of g of x is equal to negative 3. So over here, the whole function is equal to negative 3, not just x. So the whole function is equal to negative 3. So once again, I'm going to label my outer and inner function. F of f is still our outer function because it comes first. G is our inner function. So I'm going to set it up exactly the same way. So I have 2 times that blank for x because I'm going to plug in g of x in for that x minus 1. The important part here is this whole thing equals negative 3. So I'm going to set that up right away. That equals negative 3. I'm going to plug in my inner function, which is g of x, in here. Same thing. I'm going to take 2 times 3x is 6x minus 1 equals negative 3. What am I going to do here? Add 1 to both sides. 6x equals negative 2. Divide both sides by 6. X equals negative 1/3. And that is my final answer. So notice here that we solved for x. Over here, we solved for the value of the entire function. So when the whole thing equals a number, know that we're going to be solving for x. Over here, we're just solving for the value of the function. So how can we tell the difference? Over here, we see that there's an equal sign. I'm going to circle this in purple. This is an equal sign, which I know I covered it up, but that's the equal sign. Over here, you can see it's in parentheses, and that's the difference. If you have any questions, once again, please call over me or Miss Avra. Otherwise, stop. It's practice time. So you can pause the video here, and then we will pick back up in 1 second. So hit pause now. And if you didn't hit pause, which you were supposed to, now we're back. We are going to start with station 2. So there's 2 different portions to station 2. I'm going to pull this in case you're scrolling through. This is station 2. And now we're going to get started. So this is throwback to log properties in the inverse relationship. So we have log base 10 of 5 plus log base 10 of 2. So here we have when adding logs with like bases, multiply the argument. So I'm going to multiply my arguments. I have log base 10 of 5 times 2 equals log base 10 of what's 5 times 2? 10. So that's a good way to start this one. Here we have when subtracting logs with like bases, divide the arguments. Do this one in a different color. I have log base 10 of 5 divided by 2. I can rewrite that as log base 10 of 5 over 2. That's a good way to leave it. And the last one, we have a coefficient in front of the log becomes an exponent. Becomes an exponent on the argument. So once again, I'm going to take this 2, swing it up to become an exponent. So I end up with log base 10 of 5 to the second power, which is the same thing as log base 10 of 5 times 5, which is 25. So we have log base 10 of 25. Once again, this is a good time to stop and practice these below. It's not a new station, so if you want to keep watching, that's fine. I think now would be a good time to practice these. Otherwise, moving on, we are going to work on finding the inverse, which I know this has been a minute. So what's the first thing we should do when it says find the inverse? It's switch x and y. So we have this x and this y, and we're going to flip them. So rewriting that, we have 10 to the y equals x because I flipped those two. And now we are going to solve for y to get that y by itself. So how do I do that? We are going to take the logarithm of both sides. I like to just think of it as taking log base 10. You can also use circle method to go from exponential to log form. I'm going to do it the other way. So I have log base 10 of this side. That means I have log base 10 of this side. These cancel. So I end up with y equals log base 10 of x. And that's my answer because I have y by itself. That was my goal. Once again, over here, it says find the inverse. That means I flip my x and my y. So I end up with log base 10 of y equals x. I believe that's flipped. Now I need to find, get x by itself. So I'm in logarithmic form. I'm going to go to exponential. So I'm going to set up my boxes. And I start here with my base. So my first number is going to be 10 over to the other side of the equal side. So 10 to the power of x equals back over this way equals y. So at the end of the day, I end up with 10 to the power of x equals y. That's my inverse. So this is a great time to stop the video. Stop, it's practice time once again. And yeah, pause here and practice. Moving on to station 3. In case you are fast forwarding, station 3 is right here. I know I wrote that badly. It's not my fault. My handwriting stinks. I'm very sorry. But we'll get started with this one. So, Google Classroom video for station 3. We have solving exponential and log equations. So this is what we've been doing the last couple days. So we're going to have fun with this one. We have natural log of x minus natural log of 3 equals 4. So the first thing I see when I look at this is on this side, I see that I am subtracting my logs. So that means I divide my arguments. I'm going to move that down a little bit so you can see that. So subtracting my logs, I'm going to divide my arguments. So I have natural log of x divided by 3 equals 4. So we're feeling pretty good about this. Nice start. Next, I want to isolate my x, which means that I am going to need to use circle method. So remember that we can rewrite natural log as log base e. That's just the same thing. So I'm going to rewrite it down here. The only thing I changed was rewriting log as log base e. So now I can use my circle method. I know I'm converting to an exponential, so I'm going to set up my boxes. I hope that's big enough. So we always start with our base. So starting here, we have e to the 4th power. I swung across my equal sign. Back over here equals x over 3. So I'm going to rewrite that underneath. E to the 4th equals x over 3. This is just the same thing. I want to get this x by itself, so what can I do? I'm going to multiply both sides by 3. X equals 3e to the 4th. I don't know what that is as a number that doesn't involve e. I'm going to grab my calculator. So I'm going to go here. It's 3. Reminder that the e button is over here. So 3e to the 4th power. That equals 163.79. 794. It only goes one more, so I'll include it. So again, if you have any questions about that, please talk to me or Miss Avra. Otherwise, we're moving on. So we have e to the power of b minus 3 equals 6. So here I am solving for my b. So I see that I have that in an exponent, so I need to get that b minus 3 out of the exponent. How do I do that? I need to take the natural log of both sides, or log base e. So I take log base e of this side, log base e of that side. I know you can't see that. These cancel. I end up with b minus 3 equals log base e of 6. You can use natural log too. That's totally fine. I think it makes it a little bit easier to see when we use log base e. So we have b minus 3 equals log base e of 6. Reminder that log base e of 6 is a number. So what do I need to do? I need to get b by itself. I'm going to add 3 to both sides. So I end up with b equals log base e of 6 plus 3. Reminder that this log base e of 6 is its own entity. That's a number, so we can't combine this plus 3 with our log base e of 6. So I'm going to type this into my calculator. I end up with b equals, reminder, log base is over here. Log base, I type in e. It gives me a little exponent box. You can just delete that. Log base e of 6. And then over here, plus 3. Nope, that was plus 1. Very sorry. We have plus 3. That gives me 4.79. So b equals 4.79. If you have any questions about that, you can ask me or Miss Avra, and we will come answer any questions. So at this point, it's practice time. Last one, if you did not stop and practice, that was a very awkward transition, and I'm sorry. If you did, I'm sorry. It's awkward now. But here we go. Station 4, starting right here. If you're scrolling through, that's for you. Should be enough time. Okay, here your copy should be correct, but we have 3 to the power of x minus 1 equals 6 to the power of 3 minus 2x. Oh man, here we go. So this is one of our problems that's using unlike bases. Reminder, if we have unlike bases, we use natural log. That's what that says, ln. Or if anyone's getting mad about my handwriting, I'll try and write this really neat. Natural log. There it is. Okay. So first step is we're going to take the natural log of both sides. So I'm going to take the natural log of here and the natural log of here. And that leaves me with the natural log of 3 to the power of x minus 1 equals natural log of 6 to the power of 3 minus 2x. Once again, here we use the property of logarithms called the exponent property, where we take our exponents and we swing them down in front to become coefficients. So that leaves me with x minus 1 times the natural log of 3 equals 3 minus 2x times the natural log of 6. So once we get here, I know I want to get my x's to one side. Right now my x's are both caught up in parentheses, so I'm going to distribute, because remember this is multiplication happening here, my natural log of 3 to both sides. So I end up with x natural log of 3. I'm going to go minus natural log of 3. Remember, or reminder that there's a 1 right there, but you can just rewrite it as natural log of 3 equals, I'm going to do that in pink. Same thing over here. There's multiplication happening. I'm going to distribute my natural log of 6. So we have equals 3 natural log of 6 minus, that should be in blue, my bad, minus 2x times natural log of 6. So now I can combine my like terms, which I tried to color code. Sorry if that's not coming across very clear. But I know I want to get my x's to one side. So I have an x over here. I'm going to add, I flipped that. That's very confusing. I'm sorry. Okay, so I was going to color code so my x's are different colors, but turns out I just color coded the first and the second. So that's not super helpful. So ignore the color coding and think about the x's. So we have an x here and an x over here. So I'm going to combine those two. So I'm going to add 2x natural log of 6 over here. And I'm going to add 2x natural log of 6 over here. These will cancel out because they're the same. So I'm left with x natural log of 3 plus 2x natural log of 6. Reminder, I still have that minus 1, so minus natural log of 3 equals 3 natural log of 6. So we're going to bring that down. All right, we're looking good. Here, notice on this side I have an x and an x, that's good, but I have this extra guy right here. Oh man, that's the bell. All right, so we have this natural log of 3 over here. There's no x here, right? So I want to get that out of there. I'm going to add this to both sides. So I'm going to add natural log of 3 here and add natural log of 3 here. These can cancel because inverse properties and such. Boom, boom, boom. So we're left with this. So I'm going to have x natural log of 3 plus 2x natural log of 6 equals 3 natural log of 6 plus natural log of 3. So this is looking pretty good. I'm going to rewrite this up here at the top because then we need a little bit more room to finish up. So I'm just going to rewrite it. So don't freak out. Rewriting it. X natural log of 3 plus 2x natural log of 6 equals 3 natural log of 6 plus, please have enough room, natural log of 3. I know that's tight, but we're just rewriting it right here. Looking here, I know next I want to get an x by itself. So I see I have one x right here, and I have another x right here. So I'm going to pull those out. So I have x times, if I pull out next, what's left? Natural log of 3 plus, if I pull out next, what's left? I have 2 natural log of 6 equals that same right side, right? So we have 3 natural log of 6 plus natural log of 3. So I see I have that x right here. I want to get that by itself. So I'm going to divide both sides by what I'm multiplying by, which is this. Natural log of 3 plus 2 natural log of 6 divided by natural log of 3 plus 2 natural log of 6. Because these will cancel and those won't. So at the very end of the day, I have x equals, and I'm going to write this out. So I have 3 natural log of 6 plus natural log of 3 over natural log of 3 plus 2 times natural log of 6. And this is my final answer. If I want to plug this into my calculator, this is kind of a mess, but we're going to do it together. Have it there. 3, oops, not if I can't type. 3 natural log of 6 plus natural log of 3 divided by natural log of 3 plus 2 times natural log of 6. That gives me about 1.38. That is also an acceptable answer if you're fast forwarding. If you have any questions, please let me know, or if I made a mistake, which is also probable, also please let me know. But hopefully these videos were helpful. And for one last time, this is your practice time. If you have any questions, please call me or Miss Avra over, and good luck with your quiz review.